Modeling a set of data with linear functions. Real-world situations including two or more linear functions may be modeled with a system of linear equations. Remember, when solving a system of linear equations, we are looking for points the two lines have in common. Typically, there are three types of answers possible as shown in Figure 5. We can either have two lines that intersect exactly at one solution. We can have two lines that are equal to each other, which would make this infinitely many solutions. Or we can have two lines that are parallel that would make that no solutions. Now, given a situation that represents a system of linear equations, we're going to write the system of equations and identify the solution. Number one, identify the input and output of each linear model. Number two, identify the slope and the y-intercept of each interlinear model. And number three, find a solution by setting the two linear functions equal to one another and solving for x, or find the point of intersection on a graph. Now for example 4, building a system of linear models to choose a truck rental company. Now Jamal is choosing between two truck rental companies. The first, Keep On Trucking Incorporated, charges an upfront fee of $20, then 59 cents a mile. The second, Move It Your Way, charges an upfront fee of $16, then 63 cents a mile. When will Keep On Trucking Incorporated be the better choice for Jamal? Now for step number one, the two important quantities in this problem are the cost and the number of miles driven. Because we have two companies to consider, we will define two functions in this table. Well, the input, D, is going to be the distance driven in miles. The outputs, K of D, for Keep On Trucking, that's the cost in dollars for renting from Keep On Trucking. M of D is the cost in dollars for renting from Move It Your Way. Now, the initial value is the fixed cost. So the upfront fee for K of 0 is $20, and the upfront fee for M of 0 is $16. Now, the rate of change for Keep On Trucking is 59 cents per mile, where the Move It Your Way is 63 cents per mile. So this should be an M, not a P. Now, in number 2, a linear function is of the form f of x equals mx plus b. We're going to use the rates of change and initial charges. We can write the equations. K of d is equal to the rate of change, 59 cents per d miles, plus 20 being the fixed cost. M of d is going to equal 63 cents per d miles, plus the fixed cost of 16. Now, using these equations, we can determine when Keeping On Trucking Incorporated will be the better choice, because all we have to make that decision from is the costs. We are looking for when Move It Your Way will cost less, or when K of D is less than M of D. Now, the solution pathway will lead us to find the equations for the two functions, find the intersection, and then see where K of D function is smaller. So these graphs you can see are sketched in Figure 6, with KD being in red. So you can see here that the red is above the blue, and then they intersect at this point, meaning they're both are equal, and then the blue is then above the red. Now, to find the intersection, we're going to set these equations equal to each other and solve. We're going to set the function K of D equal to the function M of D. So we have 0.59D plus 20 and 0.63D plus 16, and we're going to solve for D. So we can subtract 0.63D to the left to get negative 0.04D. Subtracting 20 to the right side gives us negative 4. Divide both sides by negative 0.04, then the distance traveled for when they're equal to each other would be 100. Now this tells us that the cost from the two companies will be the same if 100 miles are driven. So either by looking at the graph or noting that K of D is growing at a slower rate, we can conclude that Keep On Trucking Incorporated will be the cheaper price when more than 100 miles are driven, and that is D is greater than 100.